Hello everyone, and welcome back to another video. In today's lesson, we'll explore the Unconfined Compressive Strength, UCS, test. So, stay with me until the end, grab your notes, and learn how to calculate the friction angle, determine the coefficient of internal friction, and understand the concept of shear failure in rocks. Let's get started. As the applied load gradually increases, carefully observe the rock specimen. Eventually, shear failure occurs. Notice that the failure plane is inclined, indicating that the rock failed in shear. This inclined failure plane is a key feature of the UCS test and helps us understand the rock's failure mechanism. Now, let's look at the first sample that we already showed earlier in the video. As you can see, a vertical load is applied to the rock specimen. As the load increases, the specimen fails by shear, forming the shear failure plane, which is shown by the dashed orange line. Now, let's identify each term shown in the figure. First, we have the shear failure plane. It is the plane along which the rock fails by shear and slides under the applied stress. Next, we have sigma 1, which is the maximum principal compressive stress acting on the rock specimen. It represents the loading direction during the uniaxial compression test. Now, let's look at theta. This is called the failure angle. It is the angle between the shear failure plane and the loading direction, sigma 1. The next angle is beta. It is the angle between the shear failure plane and the horizontal plane. Finally, we have the internal friction angle, phi. If we assume that the rock follows the Mohr-Coulomb failure criterion, then theta equals 45 degrees minus 1/2 of phi. By rearranging the equation, we can say that phi equals 90 degrees minus 2 times theta. This means that once we measure the failure angle, theta, we can easily calculate the internal friction angle, phi. Now, let's start with a quiz. The following cylindrical rock specimen failed under a uniaxial compression test. The major principal stress, sigma 1, is equal to 3,500 pounds per square inch. Your task is to answer the following questions. First, measure the failure angle, theta. Second, determine the angle, beta, which is the angle between the shear failure plane and the horizontal plane. Focus on the solution. Step 1. Using a protractor, measure the angle between the shear failure plane and the major principal stress, sigma 1. Place the center of the protractor at the intersection point, align the 90-degree mark with the loading direction, and read the angle to the shear failure plane. From the image, the measured failure angle, theta, is approximately 24 degrees, plus or minus 2 degrees. Step 2. Next, let's calculate the angle, beta. Because the horizontal plane is perpendicular to the loading direction, beta is simply the complement of the measured failure angle. Since theta is 24 degrees, beta becomes 66 degrees. This value will be used in the next step to calculate the internal friction angle. Step 3. Now, let's calculate the internal friction angle, phi. According to the Mohr-Coulomb failure criterion, theta is equal to 45 degrees minus 1/2 of phi. To calculate phi, we first rearrange the equation. This gives us phi equals 90 degrees minus 2 times theta. Now, substitute the measured value of theta, which is 24 degrees. The internal friction angle of this rock sample is 42 degrees. And that's all for today. I hope you found this exercise helpful and gained a better understanding of shear failure, the failure angle, and the internal friction angle. If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and turn on the notification bell so you never miss our upcoming geology and geomechanics tutorials. You can also follow GeoInsights on YouTube and LinkedIn for more educational content, practical examples, and professional insights in petroleum geomechanics. Thank you for watching, and I'll see you in the next video.